Did you know that hydrocarbons are a primary source of energy globally? In today's class, we'll be looking at hydrocarbons, laying emphasis on a specific type of hydrocarbons called alicyclic hydrocarbons. At the end of this lesson, you should be able to define hydrocarbons, list the types of hydrocarbons, identify and name simple hydrocarbons, and explain the properties and uses of hydrocarbons. Now let's get to class. So what comes to mind when you see things like this? What do you know about hydrocarbons and their uses? So what are hydrocarbons? Hydrocarbons are organic compounds composed of carbon and hydrogen only. From the name, it can be inferred that these are organic compounds composed of two elements, hydrogen and carbon. Aliphatic hydrocarbons, on the other hand, are those hydrocarbons in which the carbon atoms form either straight chain or branched chains, which are also called alicyclic, or rings, which are also called cyclic hydrocarbons. Over the years, these compounds have proven to be very important and significant in the running of our daily activities. From the electric power generation to industrial activities to transportation to commercial activities, just to mention a few. For instance, this chart shows the use of hydrocarbons in the United States. The electric power generating sector used about 35%, the industrial sector used about 33%, the commercial sector used about 12%, and we have transportation, which is quite common amongst us, using a total of about 3%. Now, if 3% of hydrocarbon usage is allocated to transportation in the United States, then it means that there is a whole lot of hydrocarbon that is used every day in the industrial sector, in the electric power generating sector, and even in the commercial sector. So hydrocarbons are very important, and they are widely used in the running of many engines as a source of fuel. Now, let's look at the types of alicyclic hydrocarbons. There are two main classes of alicyclic hydrocarbons, namely saturated hydrocarbons and unsaturated hydrocarbons. Saturated hydrocarbons are characterized by the presence of a single covalent bond between carbon atoms, while unsaturated hydrocarbons are characterized by the presence of multiple bonds, which could either be double bonds or triple bonds in between carbon atoms. Now let's take a look at a saturated hydrocarbon. This hydrocarbon is composed of carbon linked by a single covalent bond, which makes it saturated, and hydrogen. Since this compound is composed of only carbon and hydrogen, it is a hydrocarbon. And since this compound contains a single covalent bond between carbon atoms, then it is saturated. Now, a close look at the unsaturated hydrocarbons, such as alkenes and alkynes, shows that alkenes are characterized by the presence of a double covalent bond between carbon atoms, and alkynes are characterized by the presence of a triple covalent bond between carbon atoms. As a result, both alkenes and alkynes are unsaturated due to the presence of multiple bonds. Hydrocarbons are described as saturated when they contain single covalent bonds and unsaturated when they contain multiple covalent bonds. These multiple covalent bonds can either be a double bond, as seen in alkenes, or a triple bond, as seen in alkynes. Now, having looked at the basis for saturation or unsaturation, let's look at some examples of saturated hydrocarbons, such as alkenes. The first member of the alkene family is called methane. The second member is called ethane. Now, you would notice that they are all ending with the parent name, which is from alkane. The third member is called propane. So I'm sure if I give you the prefix of the fourth member as but, then you should be able to complete the name by adding ane, and this becomes butane. Compounds derive their name from Greek words, and they end with ane, which is from the parent name. Take a look at how these prefixes are assigned. When a compound contains one carbon atom, the prefix is meth. When it contains two carbon atoms, the prefix is eth. 3 carbon atoms, the prefix is pro. For 4 carbon atoms, the prefix is but. 5 carbon atoms, the prefix is pent. For 6 carbon atoms, the prefix is hex. 7 carbon atoms, the prefix is hept. For 8 carbon atoms, the prefix is oct. For 9 carbon atoms, the prefix is non. And for 10 carbon atoms, the prefix is dec. Now, as we proceed in the class, recall that these compounds end with the parent name ANE. So for a saturated hydrocarbon with 1 carbon atom, the name is methane. For a saturated hydrocarbon with 2 carbon atoms, the name is ethane. A saturated hydrocarbon with 3 carbon atoms will be propane. A saturated hydrocarbon with 4 carbon atoms will be butane. A saturated hydrocarbon with 5 carbon atoms will be pentane. So I'll give you a minute to tell me what the names would be for hydrocarbons with 6 carbon atoms down to 10 carbon atoms. All right, so you see, just by adding ANE, then we have the names of these hydrocarbons. Now, what if these hydrocarbons are not saturated? What if I have an unsaturated hydrocarbon, such as an alkene? Now, recall that while we were naming saturated hydrocarbons, we followed these prefixes, but ended with ANE. Now, in this case, we would follow the same prefixes, but end with ENE. So let's take an example with the third carbon atom. An alkene having 3 carbon atoms is going to end with PENE, propene. Let's move on to the 7th carbon atom. For the 7th carbon atom, we're going to have heptene, ENE. And the same also applies to alkynes. Members of alkynes end with YNES. So for an alkyne that has just 2 carbon atoms, called ethyne. So let's go with the 5th member. For an alkyne with 5 carbon atoms, it will be called pentyne. So take note of the fact that these compounds end with their parent name. Alkenes end with ANE, alkenes end with ENE, and alkynes end with YNE. Now let's take a look at the 6th member of alkenes, alkenes, and alkynes. Recall that the 6th member has a suffix hex. Therefore, the 6th member of alkenes is hexane. The 6th member of alkenes is hexene. And the 6th member of alkynes is hexyne. Now, when these names are given, there are specific rules that must be followed. The first rule is that when all the carbon atoms form a continuous chain, it is called by its Greek name. So we have just looked at some Greek names like hexane, hexene, and hexyne. We have also looked at Greek names like butane, butene, and butyne. The second rule is that the name of a branch chain is determined by the number of carbon atoms in the longest continuous chain, because the name depends on the longest continuous chain. Rule number 3, if a substituent is present, the substituent becomes the prefix joined to the parent name. If a substituent, what are examples of substituents? Substituents are heteroatoms or groups like methyl group, nitro group, bromine, chlorine, which all belong to the halo group, the ethyl group. So when groups like this are present, then the name of the group becomes the prefix joined to the parent name. Recall that the parent name is formed from the longest continuous chain. Rule number 4, assign numbers or locants serially to the carbon in the parent chain, starting from the end closest to the side chain, the substituent or the functional group. Now, looking at this example, how do I go about naming a compound like this? Now, to name a compound like this, then I need to follow the rules designated by IUPAC. This means that this compound, which has 5 carbon atoms forming a continuous chain, is going to earn its name from the Greek name. So 1, 2, 3, 4, 5. Recall that 5 is pent. And since it is saturated, meaning that there are no multiple bonds anywhere, then there is a pentane somewhere in the naming. Rule number 2 says the name of a branched chain is determined by the number of carbon atoms in the longest continuous chain. Rule number 3 says if a substituent is present, the substituent becomes the prefix joined to the parent name. Examples of substituents are the methyl group, the ethyl group, the nitro group, the halo group, such as chlorine, bromine, and so on. Now, when any of these substituents are present, then the substituent becomes the prefix joined to the parent name. Now, recall that by following rule number 1 and 2, we have the parent name as pentane. Now, the substituent that is present here is CH3, which is a methyl group. But before I go ahead to add methyl to the parent name, let's look at rule number 4. Rule number 4 says assign numbers or locants serially to the carbons in the parent chain, starting from the end closest to the side chain, the substituent or the functional group. So far, we have established that this is the parent chain, composed of 5 carbon atoms. And that was how we got the name pentane. Now, to assign numbers or locants to the carbons in the parent chain, I'll start from the end closest to the carbon atom carrying the substituent or the side chain. This means that I'll start counting from this carbon atom. So this is carbon atom 1, 2, 3, 4, and 5. Now, these numbers show that number 2 has been assigned to the substituent, which is methyl. Therefore, this compound becomes 2-methyl pentane. Rule number 5 says when identical substituents are on the same carbon chain, the locant is repeated as many times as required and separated using a comma. Then rule number 6 is when there are more than one substituent, the substituents are arranged in alphabetical order. So look at more examples as we proceed in the class. Now let's look at these exercises together, applying what we have learned so far to draw the structure of these organic compounds that have been outlined here. And from what we have learned so far, if a compound has the name butane, then going by the prefix but suggests that there are 4 carbon atoms. And since it ends with ANE, it suggests that it is saturated and there are single bonds existing between carbon atoms. Now, since it is a hydrocarbon, then I have hydrogen atoms surrounding the carbon atoms. So this is butane. And in the condensed form, this can be written as CH3, which is this section, then CH2, CH2, and CH3. Now for 2-methylhexane, recall that number 2 is a locant showing us the position of the methyl substituent, while the hexane, which is the parent name, tells us that there are 6 carbon atoms in this compound. Since it ends with ANE, it also implies that there are only single bonds existing between carbon atoms. So 6 carbon atoms, 1, 2, 3, 4, 5, and 6. Number 2 shows that there is a methyl substituent on the second carbon atom. So this is the methyl substituent. And then I have hydrogen atoms surrounding it. Okay, so and then the condensed formula is CH3, CH2, 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 CH, open bracket, CH3, close the bracket, CH3. So I wanted to try out this one. Now, let's take a look at the physical properties of these compounds. Alkane, alkene, and alkyne are all non-polar substances. Therefore, they are insoluble in water, but they are soluble in organic solvents such as hexane. Secondly, their physical properties such as boiling point, melting point, and density increases as the number of carbon atom per molecule increases. However, the boiling and melting point increases as we move from alkanes to alkenes and then from alkenes to alkynes. Now let's look at the chemical properties of these compounds. All the three classes of hydrocarbons undergo combustion reactions, and that is why they are a major source of fuel, both at the industrial and domestic level. Now, alkanes undergo substitution reaction, while alkenes and alkynes undergo addition reaction due to the presence of unsaturation. Alkenes do not decolorize purple KMNO4, which is an oxidizing agent, while alkenes and alkynes decolorize KMNO4. Now, this can be used as a simple test to distinguish between saturated compounds and unsaturated compounds. Let's look at some of the uses of these hydrocarbons. Alkanes are a useful source of heat. For instance, a mixture of liquefied propane and butane is used as household cooking gas. Bromoethane is used in the production of tetraethyl lead, which is an additive to petrol that is used as an anti-knock agent. Now, uses of alkenes. Alkenes such as ethene and propane are used to make plastics. Ethene is used in the production of ethanol and in the ripening of fruits. Uses of alkynes. A mixture of oxygen and ethyne, which gives oxyacetylene or oxyethine, is used in welding, and then ethyne is used in the production of PVC. In conclusion, we have looked at the two classes of hydrocarbons, which are saturated and unsaturated hydrocarbons. Saturated hydrocarbons are characterized by the presence of single carbon-carbon bonds. Unsaturated hydrocarbons are characterized by the presence of carbon-carbon multiple bonds, which can either be double bond or triple bond. For compounds composed of carbon-carbon single bonds, they are called alkanes. Compounds composed of carbon-carbon double bond are alkenes, while those composed of carbon-carbon triple bond are called alkynes. These compounds are very useful in our world today because many of them serve as a source of fuel, which helps us run many engines. We have also looked at how to name these compounds using their parent name, taking note of substituents and attaching or assigning locants or numbers to these substituents in order to show the position of these substituents in the compounds.